Right, so when you're working with variable acceleration, or when you're trying to spot whether or not you can use SUVAT formally rather than variable acceleration, the clue is generally in the fact that the motion is described as a function of time. So you'll be given an expression either related to the acceleration, the velocity, or the displacement as a function of time, as we can see here. And this is what you have to commit to memory, is that depending on where you are, what function you're given, so if you're given a velocity function relevant to time, and you want to find displacement, then you're going in that direction, and it's integration. If you're traveling from velocity to acceleration, then it's a differentiation that you need to do. So that is something that you need to commit to memory. So let's have a look at the sort of question you would have had presented to you in AS in the Unit 2. So we have a particle P moving along a straight line. At time t equals 0, the particle is at point A and is moving with velocity 8 meters per second towards a point B on the line where AB is 30 meters. So a typo there. At time t seconds, where t is greater than or equal to 0, the acceleration of P is 2 minus 2t meters per second squared in the direction AB. Okay, so let's just put that on a little diagram just to help us. That's supposed to be a straight line. We have A there, and at A we know that t is 0. Time t equals 0, the particle is at point A and is moving with a velocity of 8 meters per second. And in general, motion, when we draw it, we're moving on a page from left to right. So if that's point A, point B is here, some way further down the line. Now we know that AB is 30 meters. And we have the acceleration in terms of t. Find an expression in terms of t for the displacement of P from A at t seconds. So in order to get the displacement, which is s, I have to go from my given function, which is A, so I have to integrate it first of all to get velocity and then to get displacement. So velocity is the integral of A with respect to t, which is the integral of 2 minus 2t dt. Let's get rid of that diagram now. So when we integrate that, the 2 becomes a 2t. We add 1 to the power of t and divide by that, so that's going to become 2 squared. So it'll be minus 2t squared over 2, and then we have to put in our constant. So the 2's will cancel, and in order to figure out the constant, I need to look at the detail in the question to see whether at any particular given value of t I know a related value of v, and I know that at time t equals 0 it's moving with a velocity of 8. So when t equals 0, v equals 8. So the t equals 0 will take out both variable parts of that, which means v equals c, so c equals 8. So my velocity expression will be 2t minus t squared plus 8. Then I have to go a second time because I'm looking for an s equals expression. So now s equals the integral of v dt. So s is the integral of 2t minus t squared plus 8 with respect to t. So s will now be, so add 1 to that, divide by 2, so 2 over 2, t squared for that first term, minus 1/3 t cubed, plus 8t plus a constant, which we then have to eliminate again. So now we're looking for knowledge from the question linking an instant of time with displacement. And it's telling me at time t equals 0, the particle is at A. So when t is 0, displacement is 0. So therefore, c is 0 because each part of that expression has a t in it, which will be 0. So therefore, c equals 0, hence s equals t squared minus 1/3 t cubed plus 8t. So find an expression in terms of t for the displacement of p from A at t seconds. We've done that. Part B. Show that p does not reach B. So just to keep on the same page, I'll do part B here. So show that p does not reach B. So that means that before it's travelled 30 meters, it's going to come to a halt. So particle comes to rest, and that is going to be an instantaneous rest. It doesn't halt because we're not given an upper limit for the time. Then this is going to keep going infinite. This particle will travel for an infinite period of time. So comes to rest instantaneously when v equals 0. So we have our expression for v there. So that means i.e. 2t minus t squared plus 8 equals 0. Don't like having a negative quadratic part to the term, so I will write that like that. So that's one that we could just factorize or use our equation solver. Let's use that so that we're just refreshing our memory how to find it for a more complicated one. So menu, and you're going down to the equation solver, and we want a polynomial degree 2 to get our quadratic, coefficient of 1, coefficient of -2, coefficient of -8. So first solution is x is 4, the second is -2. The context of the question is time, so we can disregard the -2 and get time is at 4 seconds. So that particle is going to travel for 4 seconds towards B, instantaneously come to rest, and then change direction to go in the other direction. So the question is, show that P does not reach B. Well, we haven't done that yet. We know that it's going to instantaneously stop at 4 seconds, but there's nothing in that mass to say that 4 seconds is beyond B. So we now need to find the displacement at that time. So at t equals 4, into now our displacement expression. So into that, go back into the arithmetic calculator, so normal mode, and what I'm going to do is store 4 in x, and then I can just write that expression as x squared minus, and then as a fraction, 4 cubed on the numerator, 3 is the denominator, plus 8 bracket x. So I put a 4 there, that could have been an x. So then you press equals, and you get 26.7, or 26 and 2/3 meters. Which is less than the 30-meter distance to B. So now we have shown that P does not reach B. And then part C, find the value of T when P returns to A, giving your answer to 3 significant figures. So if I do that here, so the time when it returns to A, then it's travelled from A to B and back again, so its displacement is once again 0. Its displacement from A is 0. It's back where it started from. So at A, S equals 0. So here is our expression for S. So T squared minus 1/3 T cubed plus 8T equals 0. At first sight you're thinking that's a cubic equation, but because there's no constant term I can take T out as a common factor, leaving me T minus 1/3 T squared plus 8. So now either T is 0, which is where it starts from, and we were given that in the question. So we know that one, or this expression is 0. And if I just change to make the squared positive, so I've got 1/3 T squared minus T minus 8 equals 0. Put that into my equation solver. So the first one is 1 divided by 3. The second one is -1 and -8. So the first value of T is going to be 6.623 blah 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 blah, which is positive, so that's possible. So either T equals 6.623 dot 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 dot, and if we hit it a second time we get a negative value, so we can disregard that. So we've got either T is 0, which we know about, or T equals 6.623. Just check back to the question. They want the answer given to 3 significant figures. So for 3 significant figures, that's going to be 6.62. So 6.62 to 3 significant figures. And then part D, find the total distance travelled by P in the interval between the 2 instances when it passes through A. So it leaves A, it travels for 4 seconds when it becomes instantaneously at rest. At that point, it's a distance of 26 and 2/3 meters from A. It then changes direction and travels back to A, so the distance that it will have travelled will be twice the 26 and 2/3. So find the total distance travelled will be 2 lots of 26 and 2/3 so 26 and 2/3 times 2 equals 53 and 1/3. Is off the page. So 53 and 1/3. So that's pretty much covers the variable acceleration sort of challenge you would have had at AS.